Okay, actually, I'm recording now. I was talking for a couple minutes before I realized I was not recording, but I'm just figured I'd hit record while I looked over some Himalayan research. Just looked around. I'm not prepared to do some like exquisite presentation on anything, but I'm just gonna go ahead and just kind of research and record it. I feel I'm in a position where I can effectively, hopefully, make some like interesting finds along the way. So, without further ado, continental collision that triggered the formation of the Himalayas. Yeah, so we'll come to a complete halt in 20 years. 20 million. 20. Continue to rise 1 centimeter a year. This to me, like, if this is a mountain chain literally that a supernova within the Earth caused, then it would make sense that it's still like a gas cloud moving away from the supernova and lifting up kind of thing. Like, it's not really. It's got a supernova behind it, so it's still moving. That would make sense. That a supernova could do that. And I just say the word supernova. I know generically, obviously, a supernova is a star, and this is a generic term that is I'm applying to anything, any particle that explodes. That's like a particle. So an excited electron is a supernova, effectively. It's literally the same mechanic. It is a supernova. I could say every time the excited electron of the Earth becomes excited, but it doesn't really carry the understanding that supernova really like brings to mind. Like it is a supernova. So it's just a different scale and a particle within the Earth's supernova creating the Himalayas. And maybe in a future time when we realize this to be the case, these things to be the case. I know there's kilonova and other forms of novas. Maybe just the general nova with a more specific term to it, like not super, because that's for stars. It maybe would be more appropriate, so pardon me. But generally speaking, the particle then supernova creating the Himalayas. That's what I'm investigating. This here, I noticed crystalline, which is interesting that there's zones of the Himalayas that are literally called crystalline zones. It's just interesting. If a supernova is involved, maybe it can make a certain degree of order just by the like uniform explosiveness of it all to create some sort of crystallinity in the overall appearance of the mountain chain. Just a thought. I don't know why they call it that. Let's see if Google Himalayan crystal. I guess it's just a term that I'm sure has a meaning somewhere, but it's so established, it's probably hard to find someone defining it more than just talking about it. Because it doesn't seem like an easy term to find. It's just bringing up papers. Maybe this. entire Himalayan crystalline belt. I guess it's just a belt. Tethyan crystalline. So this is probably considered to be from the Tethys Sea, and this is considered to be something else. These were tectonically extruded as a consequence of the southward directed propagation of crustal deformation. So this, to me, is certainly supportive of a southward propagation in general of things. Just the energy flow is southward propagating. The blah 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 are exposed through tectonic zones within the hinterland of this place. Records history of at least one episode of pre-Himalayan deformation, 3 episodes of Himalayan deformation. The rocks, so this is interesting. Really gotta just like keep up with my videos. That's sad truth, because I'm gonna talk about things that like are gonna just draw on previous videos, like the Earth, overall Earth. Maybe I can find it. I don't know. Can I find my clips? My clips that I've cut. Your clips.
Continental rifting is the breakup.
So we're gonna see the. Pardon me, sir. We're gonna see Antarctica in this segment down here fracture away. Right like that. And Beetlejuice, not Beetlegeist, Beetle. Oh my god, no. Beetlegeist. There, that's it. Beetlejuice is blue, its top. Blowing its top. Oh, not there. There it is. Astronomers have concluded. So this star blew its top, so I believe this star is about to supernova. And that ties into this because the Earth itself already supernovaed, which is what happened to go from a Pangea-esque world to a modern world. There was no ocean, the Earth expanded, and it did so in a supernova process that had different stages in the sequence that are marked by major extinction events, which are largely fossil of things that were created by the Earth expansion process. But that's besides the point right now. But the top blue, so it has these repetitive stages, and then it actually, in 66 million years ago, it actually blows its top, or it actually physically supernovas. The whole of this system supernovas here, and that's when like all of the actual, like they're just kind of cheating here and just allowing this to just float here conveniently as they move the continents into position, and then voila. But the reality is that there was no ocean floor there at all, and it's filling in space and radius. Until it is today. And so maybe when the Himalayas were being formed, that's what I was getting at, is Let's get rid of that. Get rid of that. Maybe there was at least one episode of pre-Himalayan deformation. And I just read somewhere else that there was around 500 million years ago, according to radiometric dating, there was some magmatic event in the Himalayan region. So it's like there was a precursor event, which seems to be suggested here. And then 3 episodes, like more rapid. So it was like there was a first one, and then they boom, 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 like 3 more rapid ones that occurred so quickly that in our perception they were just a couple millions of years apart, probably. I'm not completely informed, but I'm pretty sure that from what I'm reading, it's 28 to 20 million years is generally when the Himalayas are thought to have been pushed up. So I mean, it's only like 8 million years from start to finish, really, of the uplift of the Himalayas, if I believe. Besides just like some deformation. So I guess there was an episode. D2 deformation into northeast southwest trending. The problem with the Himalayas is they're so freaking big. That's probably good enough. It's probably in this general region if this is near the Himalayas. Over here. So if it's pointing like towards here, whatever they're talking about, let's see. Northwest faults, dude. Wait, where was it? Rocks of blah blah, or deformation into northwest, southeast trending. Oh, maybe they're talking about like this. The actual Himalayas are going generally northwest, southeast. Maybe. Which is kind of like this must point to somewhere. This must point somewhere. Exactly somewhere. Although it may not point at the surface, so if it points from it may point like down below the surface pretty far, which may change like its actual focal point from being like at the surface here to maybe down a little closer. But it would be real interesting if the focal point happened to be like between the chakras of the shalogram. Shalograms. Shalogram. That's why my videos are important to watch the previous ones. There's just so much. So if this points at there, that would be interesting. This does seem to have some form of 2 sides. Like here's a side-ish kind of maybe, and then another side over here. Because the shalograms tend to have 2 sides. Like, and with something here Although I was thinking the two sides of the thing that's here. Sometimes there's not to talk about this too much because I have already. There are particles that exist inside of these vortexes. So ether flows past through the rock because of the Earth's expansion process, which was due to it literally supernovaing. So it's causing energy flows to pass out of its body, essentially. And how exactly it goes through this rock, I'm not certain what the process is where this specific, the Shalograms got influenced. But essentially, energy went through the Shalograms. Ether flows went through the Shalograms. And they're not just like rocks. They are much more like this, where the rock has layers within it. Just naturally, like there are layers within the rock that where there are weak points between the layers, which is just how things form in general. And the energy passed through the rock and was able to carve out openings in these Shalograms, sometimes making them explode. But then energy flows through the, like from this one to this one, is passing through the particle that's between the things. What happened? The particle passing through to go from this side to this side. Energy passes through into this thing. So this thing's like maintained. And then I think what happens is like as the this is just higher density region. Sorry, it's not really that it's even passing through. Maybe it's more that it's not passing through it. It's that it's so dense that it's actually caused a flow around it, and then it starts to carve the surroundings, which then allows for the overall structure to behave more like a star, literally, where it is a functional particle. It's like alive. Like this is frozen and dead in a way, but it was alive. Like it was like the sun, but a mini sun. Probably these are doorways to plasma or fusion. I said plasma fusion because Eric Lerner, I know, specifically refers to the plasma fusion, and it seemed like a good idea there. And it even looks kind of like this. But, so I was like, that seems promising. It's maybe plasma. But in general, it looks like a fusion device. Because it is a fusion device, and it's like nature's like best example of a fusion device maybe that we can learn from. The way the Shalograms work. But so then the particle, I believe, rotates, causing a field from the flows. Essentially, like flows are passing by it, but then they start to go around it. Maybe they're coming this way. I think they're coming. The ones that are like that are being like, that are flowing physically within the rock from like this section of the rock to this section pass through this way. But other ones are caused to flow in a spiral here to pass around the denser region and just basically carve out the less dense material and create gaps, which then allow for basically more flows. And then once it starts to really carve out the surroundings, then the system comes to life and really has a life of its own and becomes a star and literally supernovas and all sorts of details. Like, what the fuck is this? It's even got a little particle in there hanging out. This thing is priceless, whoever bought this. It's just gorgeous. Maybe a little snake-like, and maybe people don't like that, who look at me like, could he be? Anytime I come around anything snake-like, it's just, I knew it. Oh, I saw the sixes. Fucking knew it. I fucking knew it. Okay. Back to Himalayas before I get too distracted. Different extent of transposition and a well-developed northeast plunging lineation indicate intense strain during D2, the first of the three, which is probably like after the supernova, and then these are more just like aftershocks. Supernova aftershocks. D2 is supernova, D3, D4 aftershocks of like whatever, maybe even the supernovas of in their own right. Like a radioactive decay having multiple steps, where probably the first one is still the most energetic, but then still substantial ones to follow that are not just aftershocks, they're literally subsequent decays. And maybe that even reveals something about earthquakes and aftershocks, who knows? Something more than just aftershocks, that they are like a subsequent decay of some particle on from some angle of perception, where they can be considered from that angle, and some things can be gleaned that otherwise wouldn't be. Lineation indicate intense strain during D2 throughout the studied portion of the high Himalayan crystalline. Ductile flow continued, resulting in rotation of F1 and F2 folds. I wish I could see this. Due to northeast direction and northwest. Northwest southeast plunging F3 folds. Folds that are perpendicular to the direction of the supernova source, which makes sense, as well as folds that are in the direction of the supernova source. Makes sense. No. Over thickened crystalline was finally superimposed by late to post collisional brittle ductile deformation and exposed the rocks to rapid erosion. Apatite fission track and zircon fission track studies suggest reactivation of the main central Munsieri thrust and Vakrita thrust and rapid exhumation and the system that has been in topographic and steady state since at least 4 million years. I love that they call it steady state. Oh, you're saying this after the supernova, the system has approached a steady state that we can like feel like we can put into it like something to be said in this paper where we are like, oh yeah, now it's in a steady state. Oh, okay. 3 Himalayan lithologic units, the Lesser Himalayan Sequence, Greater Himalayan Crystalline Complex. This is probably the Lesser Himalayan Crystalline Complex also. And the Tethyan Himalayan Sequence have a specific structural correlation with the main central thrust. And South Tibet detachment. So they're saying there is a correlation between the Himalayas and like this region. It sounds like Tibet. There's a correlation between Tibet and the Himalayas, but wait a minute. Didn't you guys just say India crashed in? Like, shouldn't there really not necessarily be the way they explain that away is by saying that it really penetrated underneath the Indian plates, subducted far enough to really influence the terrain up here. That's how it's explained, when it's really that there was a propagating wave in this direction that like is correlated. I mean, yeah, that would make sense if it's just a supernova literally in this direction. There, the main central thrust places. Main central thrust places the Greater Himalayan Crystalline Complex over the Lesser Himalayan Sequence, and the South Tibet detachment places the Tethyan Himalayan Sequence over the Great Himalayan Crystallines. Although this division has formed the basis for the all Himalayan tectonic models, that's good to know. It failed. Okay, so let me go back. The main central thrust places the Greater Himalayan Crystalline Complex. Maybe I can just see what Wikipedia says real quick. Just scroll through. Okay. The geology of the Himalayas is a record of the most dramatic and visible creation of the immense mountain range formed by plate tectonic forces by a supernova and sculpted by weathering and erosion. No, not really. The Himalayas, which stretch over 2,400 kilometers between, sculpted by the supernova. Much more accurately, I'd say, sculpted by the fact that it was caused by a supernova 5,000 years ago, about within the Earth. Maybe that. The Himalayas, which stretch over 2,400 kilometers. Namchabarwa. Collision of the continental crust of two tectonic plates, namely the Indian plate thrusting into the Eurasian plate. Divided into 4. Okay, maybe I won't just skip ahead. Pardon me. I just was like fresh water, world population. Dude, I'm looking for geology wise. I guess fine. Himalayan Tibet region supplies fresh water for more than 1/5 of the world's population. Okay, that's pretty significant. And accounts for 1/4 of global sedimentary budgets. Topographically, the belt has many superlatives. What is a superlative again? Just got things going for it. Superlative. Of the highest quality or degree. Highest rate of uplift. The highest relief. Among the highest erosion rates. How is it not the highest? Source of some of the greatest rivers and the highest concentration of glaciers outside of the polar regions. This last feature earned the Himalaya its name, originating from Sanskrit for the abode of the snow. From south to north, the Himalayan orogeny is divided into 4 parallel tectonic 5 thrust faults which extend across the length of the Himalayan orogeny. Each zone flanked by the thrust faults on its north and south. Okay, divided into 4 parallel and zones and 5 thrust faults. So basically a thrust fault at the beginning and end, and then 3 in the middle with 4 zones divided by those 3. I guess that makes sense. Okay. So just 4 strips. It's 4 waves of different materials that were released in the supernova. I feel pretty good about that to do that little look. From south to north, from north to south. The zones in the major faults separating them are the main frontal thrust from south. So the frontal thrust is the one in the south. That makes sense if the energy is propagating southward. Sub-Himalaya zone, also called Shivalik Hills, Shurya Hills, Outer Himalayas, that stretches over 2,400 kilometers. Is there a picture? It looks like it has its... I'm not sure if that's the whole region though. Northwest. Lesser is the lesser. Whatever. What? this one maybe actually has it. Yeah, so the south one. This is interesting, the way the orange and yellow interlock with one another. High Himalayan crystalline sequence. Followed by oceanic crust. Followed by oceanic crust of some sort. Suture zone? I'm not sure. It says ophiolites. I think that's oceanic crust. Himalaya. And then leucogranites, whatever that is. Okay. From south and main frontal thrust, sub-Himalaya zone, main boundary thrust. Lesser Himalaya, further divided into Lesser Himalayan sedimentary zone, crystalline. So the Lesser Himalayan sequence has a sedimentary zone and a crystalline zone. Crystalline nap. Moves more than 2 kilometers above a thrust fault from its original position. Main central thrust higher, greater Himalayan crystallines. South Tibetan detachment system. Tethys Himalaya. They need a map for this. Oh god. Sweet. Techno stratigraphic subdivisions. I mean, I understand why it's in this direction, but I don't think these types of things make it easy to rotate the page. Alright, fine. Okay. It's pretty much the same. It might have some undifferentiated quaternary sub-Himalayas. Sub-Himalayas. Lesser Himalayas. Lesser Himalayan crystallines. Undifferentiated. Oh, basin. Let's get a bearing on this. Maybe that's even down here. reminds me of Mount Grenard. The rocks are just separated by an energy flow process that causes separations. And then different sequences of eruption. Not the same types of rocks at all. At least not that I can tell by name, by what they call them. I don't see any similarities, really. They don't have the same names. Whether or not they're very similar chemical composition and so on, I don't know. I'm just looking at this over. So this is high, high. All the green is the high. Okay. Before I get stuck looking at that. Oh yeah, that's where I was. None of this lies on the north of this lies the Trans-Himalayan Himalaya. Trans-Himalaya where? It doesn't name it. Is it just this whole region? It must just be like the Tibetan Plateau. So it has plains in the south, which to me makes sense for if there was a supernova from the north that pushed up a wall that didn't actually reach India. So there's just those plains there. But if India had crashed into the region, I feel like India would have gotten more damage to not really have this region of just plains. Mountain range between Central Asia and Pakistan. Hangduan Mountains. These might actually be part of the Himalayas. One of them is. Oh, for sure those formed with them, and as did this. Although if this is a supernova, it makes it much harder to explain this. Why this portion happened. Because then the supernova would pretty much just form the mountains. The only way this would happen is if there was actually the mountains being formed and there was water there and there was pressure on the mountains from the water, and so the water still was able to just do that to the mountains. I don't. It just seems a little odd. Okay, not this one. Not at all. From east to west, the Himalayas are divided into 3 regions, which collectively house several nations and states. Late Precambrian was part. Oh, okay. During that period, north part of Himalaya, blah blah blah, was affected by the late phase of the Pan-African orogeny, which is marked by an unconformity between. This is while the Earth is expanding. Trans-African orogeny. Where is it? Pan-African. Pan-African. Literally doesn't show it, does it? Is it just all of it? I don't understand. They're not talking about the East African Rift Zone, are they? And all the orogenies there? Maybe they got a picture. Map of Gondwana. Arabian Nubian Shield. So that's Saudi Arabia, this Red Sea. Right? I gotta look in case I'm stupid. Okay, Red Sea. It's like that is a Red Sea, right? Oh my god. There it is. I don't think I can text search. Oh yeah. What do I want to text search? I didn't think I could text search. Pan. Oh. I didn't expect it to be. Was coined as a I used to describe tectonic, magmatic, and metamorphic activity of Neo-Proterozoic to earliest Paleozoic age, especially for crust that was once part of Gondwana. Because of its tremendous geographical and temporal extent. So how was Gondwana doing? What in the fuck is this? Are they claiming that where the fuck? Gondwana. like how they just fucking fit this together, even though it doesn't actually fit together. They show it together. Okay. Close that one. During that period, northern part of India was affected by the late phase of Pan-African orogeny, which is marked by an unconformity between Ordovician continental conglomerates and the underlying Cambrian marine sediments. Unconformity between continental conglomerates and Cambrian sediments. Underlying Cambrian sediments. Granitic intrusions dated around 500 million years are also attributed to this event. I'd really like to know exactly where they're referring to in the Himalayas. The early Carboniferous, from the end of the Devonian, early stage of rifting developed between the Indian subcontinent and the Sumerian superterrane. During that period, the northern granitic intrusions dated around 500 million years are also attributed to this event. I already read that. An early stage of rifting developed between the Indian continent during the early Permian. 300 million years. 252. 252 is pretty significant, which is kind of tied to the Siberian traps. An early stage of rifting developed between the Indians. From that time on, Smith drifted away towards the north. What the fuck? In the Norian, 210 million years ago, major rifting episode split Gondwana in two parts. When is Pangea? So really, Pangea is not where the Earth expanded from. That's like an intermediary. Because really, they're saying Pangea existed approximately 335 million years ago. I think the reason they do that though is because they need to set. They need it together. That's right. I already kind of arrived at this conclusion that they need the continents or we need in order to have plate tectonics work. we need the continents to be together at one point because we see they were, which we pinpoint at Pangea. But in order to create mountain ranges, we need to like basically like pull them apart and put them back together. That's what they do. That's what we do. We say, "Oh, this came out here, and then it went back in." And then mountains. That's how there were mountains there. So like some of these steps are literally just included for the sole purpose of mountain building or something that's like for a purpose. It's not actually the historical record shows that. It's just like we think that's what happened, and the reason we're adding this like tidbit to what happened is really because it's for the purpose of explaining this other thing. Together with us, Indians continent became part of East Gondwana together with Australia and Antarctica. However, the separation of East and West Gondwana together with... I think it would help if I looked back further than... more than Pangea, but... Gondwana...
Is it still bothering you?
No, it's fine. I'll be right back. 1 second. I'm recording. I know I'm just walking away and not going to edit it out, so I'll be right back. Okay. I was having some tooth problems. My dad was checking in. You okay? I don't even know. I don't know. Certainly not great. But okay, so this is really what's probably the actual pre-expansion Earth. Yeah, that's the problem. That's exactly the problem, though. That's the problem. That's right. I'd like to go from Pangea, where it's basically one single landmass. That's the key of Pangea. It was always one single landmass, dudes. Back here, it was one single landmass. There was no ocean. But then, to explain it being like, it's literally, that's the problem with these, is it becomes so for the purpose of like, there literally is a mountain that needs to be built here, so this is here instead of here. Like, it's literally that simple sometimes is how it's done. It's like, I don't, that's not good. That's not sufficient. Like, we're talking about what, a billion years ago supposedly, and we're gonna say that's sufficient. Oh yeah, there's mountains. They went like this. They were here. They went like this, and then they went like this. It's literally that, the Wilson cycle. It's absurd. Look at this cycle. Together, separate, together, mountains. It's brilliant. It really does explain everything if we just assume that, Pangea, pre-Pangea is allowed to just fling off component. Oh, that part wasn't there. It was out there. It was just over in this other location. It was over here. And then boom, Pangea. And meanwhile, mountains explained. We did it. It's just, it makes it hard to rely. That's the problem, is the map becomes less reliable. It's less true. Because it's just like throwing in things that are purely based on the theories and not really capturing the reality of the situation whatsoever, and instead just being false. So, let's see. Keep going. Let's just move on. So Pangea-ish time. I just don't like that they were talking in Gondwanan instead of Pangean. Like, typically that's where geology finds a pivot point, is Pangea, not so much other ones, but I guess this one's really focused on Gondwana. I just don't like it because it starts to bring in these orogenies for the purpose of orogenies, and that's the only reason that continents are moving around. Like, oh, we need to build this mountain at this time, so this chunk that conveniently must have caused it, since it's outside of it, must have hit the larger chunk. And the only way it could have done that is if it conveniently severed from it and came back and boom. Okay. However, separated together, broke off from Australia and Antarctica in the early Cretaceous, opening South Indian Sea. In late Cretaceous, a Fort Indian plate began its very rapid northward drift, covering a distance of. So we're approaching the supernova, so there's more signs of a accelerating process, perhaps. The oceanic subduction continuing until the final closure of the ocean basin, and the abduction of oceanic ophiolite onto India, and the onto India abduction. That's kind of what a supernova from under the crust would do, maybe, is to abduct outward and over top the layer that it lays on out of the earth and then lay on India. onto India. The beginning of continent-continent tectonic interaction starting at about 65 million years. When the Earth supernovaed, the change of the relative speed from very fast to fast is about 55. Circumstantial support for collision then, or just that the supernova was done and just not done, but like past its peak and now it was subsiding to an equilibrium. And so the process was displaying signs of essentially a slower process. Not that it was the collision was forcing this process to slow, although that's essentially what's happening, is the supernova under the Earth's crust of this particle that was large enough that was a pillar that the crust was resting upon, like a large chunk of crust relied on this particle to support it, and it usually is fine because it's just fine. Like this equilibrium was there, but it's not built to, like the architect wasn't prepared to build a structure to support the weights. They were like, surely we at no point will this pillar of this particle under the surface of the crust, where there's many pillars all over the crust, but this one have enough weight just over its own distribution region to physically explode. There's no way, because do you know how much water that would take resting upon the body of the Earth? It would recede to different places. It wouldn't sit on top of, surely not on top of a pillar like this. Boom. Fucking explodes. They weren't ready for it, the architect of the Earth. Or they were. They just knew. They were like, this shit needs to blow at this time. Let's make sure this pillar can't handle that water. They did like 9/11. They pre-planted little fucking micro nukes along the pillar. When it dug into the earth, they were ready. They got that particle ready to explode, to paint the picture that the water had rested upon it. But really, it was like 9/11. They just, inside job. They fucking got inside the earth, blew up the particle on their own. No, there was no airplane. Oh my god, sorry about this. That, like, a little bit at the end there. Although I like that idea. I've seen it. I've seen interesting theories. I'm open to them. 9/11. Not that I hold on to them with any certainty. Just that maybe there weren't even like planes crashing in the building. That would be crazy. I mean, obviously that would take some rapid video production to really make it look like it, and just sending them out. But like, people said it was like a missile. Anyway, besides the point. Doesn't matter. Pardon me. Pardon. The pillar, though, couldn't support it. 65 million years, that makes, is when the beginning of tectonic interaction. Essentially, when we started to notice some uplift, I guess, that's what I take that to mean. And then we see a slowing in the process, which 10 million years. Although, I mean, rotating of India by 45% counterclockwise northwestern Himalaya. I feel like there essentially was what I'm thinking is going on here is there was, just like other places on Earth where there's physical particles or polygons that are like structures that are conjoined within themselves as one unit more so than they are with the adjacent surroundings, so that energy flows can propagate between the structure. Just in the same way. What was I saying? Yeah, that there generally was maybe something in this area, like a weak point fault line type thing that it seems like maybe energy flowed through here before the supernova of the particle. It's just kind of odd that there would be like a setup of an energy flow through the region and then the supernova propagates through the region that the energy had already prepared for the supernova to propagate through. It doesn't really make sense for a supernova to be prepared for. Like, well, we got you, supernova. We know you're like that shit's about to blow. But maybe it's literally that. Just that's how things work, and not to suggest it is, but that's, again, what was I talking about? Fuck. Oh yeah, the rotation. Because the rotation, I feel I've already talked about the rotation, so it's that there is rotation of India. The rotation, I feel, can be tied to forces on that slab. The Indian continent, I mean, maybe it is like a slab of a block of material that does have its own borders, that it wasn't separate, but it was still generally there, but it was just essentially it has its own borders, which just like over here had its own borders, allowed energy to flow between it. Like this was fully closed up, energy flowed between it because of the actual border to the polygons, which I talk about in other places. Maybe this has its own polygon that had a border there in some way, that essentially in earlier parts of the vortex weapon being used, causing the Earth to expand, it began to just propagate energy. Maybe it didn't just go this way. Maybe it also went up this way through this region, and then maybe even down this like weak point that was here and like set up the region in some way. I just don't like the setup aspect of it. It seems a little silly. But it would make sense for why there would be like magma released in this general region, that then the Indian subcontinent could be like pushed, moved around a bit, as the vortex weapon on this region is just out of control, producing this seamount chain, and physically moves, causes the continent to jostle, to move around. I mean, It's not coming up from down here and swinging all in like a baseball bat. Whatcha! It's just hanging out here, and this vortex is like shoving it, causing actual rotation and counter rotation, so it rotates in both directions, like a kind of like it's doing this, rather than that it's just rotating like But the rotation actually makes it all the more ridiculous. Like to suggest it rotated in, it didn't just slide on in. It physically was rotating and came in at the perfect angle to line up and fit in. Like it's just absurd, really. I know what I say sounds absurd, but like what we say is absurd. So we need better answers than absurdity. And what I say might sound absurd, but it's not absurd. It's actually very reasonable. Because I found the theory of everything. It's as simple as that. Like, that's not even. The geology doesn't even really use physics. Sure, there's some people, but like most of the people doing this research, they rely on the other people to tell them that the other people did the part right about physics, and so they can just purely focus on geology, but that does not work. It does not work because that's not how shit works. Everything is connected. I mean, it kind of works. It allows for us to uncover the truths as we go. But at some point, we gotta reconnect the parts. Since then, there's been about 2,500 kilometers of crustal shortening and rotating of India by 45 degrees counterclockwise relative to Asia. 10 to 15 north central. So especially the rotation is, I guess, in this region. Experience more over here. I would imagine more over here too. I know the Deccan Traps experience clockwise and counterclockwise rotations. While most of the oceanic crust was simply subducted below the Tibetan block, quote simply meaning not simply at all, during the northward motion of India, at least three major mechanisms have been put forward to explain what happened since collision to the missing continental crust. Why would they say missing continental? They must mean missing oceanic crust. First mechanism also calls upon the subduction of the Indian continental crust below Tibet. Second is when in reality it's a supernova that left a pile of debris that raised the elevation of the Tibetan plateau, just not as much as the front wave that was coming in that literally produced the Himalayas, that even has the highest mountain peak generally at the center of the arc of the Himalayas, with somewhere around here, Mount Everest. There it is. There it is. Let's measure from here to here. And then again to here and see if they're about equal. 966. So if this goes to about 1920, it's a little further to down there. I did also kind of cut off some there while going completely to the end there. Oh, freaking A. I don't want to make it like exactly 1,000 there. It's pretty similar, pretty close to the center of the totality of the arc. Not near the center of this region only. That's kind of cool. I never did that. So it's around 1,000. I mean, that's around 2,000. Although, we're... yeah, near the center. Extrusion or escape tectonics mechanism. Indenter. That squeezed the Indochina block out of its way. Full text sources, publisher. Whoa. Check access. That'll be... let's see how much this costs. Become a member. Platinum members only. Become a member, let's see. Okay, maybe I can do it without paying. I'm not sure. I don't want to. Tectonics of Asia, effects of a continental collision. Okay, whatever. Second is the extrusion or escape tectonics mechanism. Mechanism third is that a large part, around 1,000 kilometers of the 2,500 kilometers of crustal shortening was accommodated by thrusting and folding of the sediments of the passive Indian margin together with the deformation of the Tibetan crust. Ongoing active collision of Indian areas challenges one hypothesis for plate motion, which relies on subduction. They must be saying that India is moving into the Himalayas because the Himalayas are rising. I wonder if they actually have a basis. The sub-Himalayan cis-Himalayan forms the southern foothills, essentially composed of Miocene to Pleistocene sediments. Okay. So there probably was water there. Internally folded and imbricated. Thrust along the main frontal thrust over the quaternary alluvium. Main thrust of frost. Frontal. Oh, there's a whole Wikipedia to just the main frontal thrust of the Himalayas. And there are probably all of them. It's geological faults in the boundary between the foothills and the plain is well expressed on the surface, thus could be seen via satellite imagery. Maybe around here. Must be talking about like here. It runs parallel to the other blades of the main Himalayan thrust. Stems from the Banda Islands to Banda Islands. Indonesia, okay. Dips at an angle of 20 to 30 degrees in the north. Like down. Ew. Wait. Sunda Mega Thrust. That's the one that runs into the Himalayas. North. Wonder if these earthquakes are literally supernovas, not just fucking like layers that are like shifting about. Like little particles down there exploding. I mean, that's probably likely after a supernova for other particles within the supernova to supernova. Okay, so this one's form of sediment. That's basically alluvium, which is flood or water deposits of particles, pretty much. Uh, Demonstrate. Da-da-da. I don't know why a plate is settlement. If it's just settlement, oh, it's just, isn't it just likely to just be some shit on top of like some more substantial rocks? That's really what's actually there. I don't know what this is about. Tectonic plate, even? I don't think this explained it well enough to make sense of why there's just sediment. There need to be other layers underneath at that point. The Lesser Himalaya tectonic plate is mainly formed by Upper Proterozoic to Lower Cambrian. Detrital. Particles of rock derived from pre-existing rock through weathering and erosion. Fragment. Classed detrital particle consist. Okay. Sediments from the passive Indian margin intercalated interembedded with some granites and acid volcanics. Thrust over the sub-Himalayan range along the main boundary thrust. The Lesser Himalaya often appears in tectonic windows within the high Himalayan crystalline sequence. Central Himalayan domain forms the backbone. So that's real interesting. And composes the area with the highest topographical relief, highest peaks. It is commonly separated into 4 zones. High Himalayan crystalline sequence. Approximately 30 different names exist in the literature to describe this unit. The most frequently found equivalents are Greater Himalayan Sequence, Tibetan Slab, and High Himalayan Crystalline is a 30-kilometer thick medium to high-grade metamorphic sequence. 30-kilometer thick medium to high-grade metamorphic sequence. How's it 30 kilometers thick if it's in the mountains? It seems a little dominant. It must be. I don't know. it's coming up 30, I guess coming up this way, and it's 30 kilometers wide. Metamorphic sequence, so some type of metamorphism, meta sedimentary, so some sort of heat involved. Maybe, is that what that is? I don't know. Formed through deposition and solidification of sediment. Subjected to high pressures and temperatures, causing recrystallization of sediment. Okay. Intruded in many places by granites of 500 million years and early 22 million years. Most of the meta-sediments forming the high Himalayan crystalline structure are of the late Proterozoic. So like right at the beginning, most of the meta-sediments forming the high Himalayas. It's very odd that there's from the Proterozoic. That's very odd. To me, it suggests that maybe the heat of this supernova of the particle under the Himalayas, causing the Himalayas, literally was able to metamorphosize surface sediments in a way to maintain their age in the ones that were on the surface, while the actual process occurred in what appears to maybe have been here at the 500 million year generally mark, and then again at the end, like an early one and then a very end one. Maybe like the energy ran into it and just couldn't do anything about it until the rest of the Earth had expanded, like fractured enough. Kind of like if you had a bunch of buttons and you needed to like sever the buttons, but there was one really, really hard to take, just huge button. It's just huge. And there's a bunch of like buttons that are still connected, and they're pretty hard to separate too. But if you really work at them, you can get them apart. Then maybe you can gather like the momentum on pulling the rest to really get the last big one to like kaboom, so that the process can occur. So maybe it just like ran into some sort of resistance here where energy flows. Could have, instead of going from Dwarka this way, could have maybe gone from Dwarka this way. I'll just get rid of that. From Dwarka, maybe through some like energetic weak point that's generally in this area somewhere, over to say here somewhere, wherever they exactly. It's like, so without going across this way, it could have maybe just gone that way, but unfortunately for the energy, it ran into this block here, like this particle that in order to do anything about, maybe just some thoughts, the energy flows had to go instead the other way and literally come from the other way. But when it did that, it brought all this water with it, which then rested upon and caused it to explode. And then really the energy channel could be somehow opened up. I don't know, just some thoughts. Pardon me as I speak thoughts. I noticed this is very common. It's very common and I appreciate it. Can I buy drugs from you? I thought it was even someone seeing my video. They didn't even see my video. It's someone else's video. On my comment, I commented, "Hey, for what it's worth, I do strongly feel that I discovered the theory of everything. The schist disk. This thing's real interesting." My comment, I'll just maybe scroll down a little at a time. If anyone cares to look at it. This right here shows a sharp mind open to possibilities, respect. I'll respond to that one and not the one that said it. I'm like, I am on drugs. You're not wrong to snake those statements. Really just weed. And you can get it from any local dispensary probably if you're fortunate enough. Okay. So, very interesting that there appears, I know this is my own interpretation and people are like, what the fuck? But it appears like there is a Proterozoic, late Proterozoic. Okay, so maybe when they say late Proterozoic, they're really talking about the period just before the Cambrian, the one that starts with an E, Ediacaran. Proterozoic, Neo-Proterozoic. I mean, they're probably talking about here. They're literally probably not talking about here or before here. They're probably talking about around 600 million and no earlier or later. No before then. Even though it says main, and then by saying main, it kind of opens the door. Or Proterozoic. It kind of opens the door to a significantly wider range. 2.5 billion years to 5. This is when Earth was in its Venus stage. I'm certain of it. There was no one here. These things were not happening while we weren't here. Not the way that a lot of them. Some of them happened, but that's other details. But these events that are all tied to one another were during the flood, when the Earth was attacked by a vortex weapon, which then caused it to expand, and then supernova, all of which appears to be starting just before the Cambrian at the Ediacaran is when the actual attack took place. And that began to produce what we see in the Ediacaran, which is fossils of certain varieties, and so on. What? Oh, Ediacaran. That's kind of cool. Like, we assume these are fossils of creatures, but they may just be energy flows that cause separations of particles and energies in ways that physically got imprinted in time and materials to a point where who knows. Although most of the sediments formed are of late Proterozoic, much younger metasediments of the metasediments. So these metasediments are sediments that were present already, are of late. Okay, these were present already. Much younger metasediments can also be found in areas. Mesozoic in the Tandy syncline of Nepal. Syncline. And Warwin Valley. Sediments, heated sediments re-metamorphosized. Where the fuck does this happen? I've never even heard of metasedimentary rocks. I know I don't know a damn thing about it, geology really, relatively speaking, but that doesn't sound very common. It doesn't sound very common. I don't think that's very common for there to be sediment that has not become so molten that it just utterly was back part of the mantle for us to in no way be able to distinguish that it was once sediment, but has become re-molten, re-solidified into a by high pressure and temperature, causing it to recrystallize. Like, how frequent do we have high pressure and temperature on sediment? That does not seem common. Limestone, metamorphic equivalent, marble. Oh. So these types of rock. Certainly not the most uncommon, but not like quartzite. I see a lot of that name maybe in passing. Marble, obviously, but in terms of like. Okay. Let's go ahead and move on. I'm not sure that that's metasedimentary rock. Okay. Metasediments represents the metamorphic equivalence of the sedimentary series forming the base of the overlying Tethys Himalaya. Major nap, which is thrust over the lesser Himalayas along the main central thrust. that makes me think of this nap thing makes me think of the ammonites. Like this sediment rock. Just like a lighter, not as hard material with a upper layer of a denser material. I'm not sure if that's what's going on here. But just that there is this slab resting on top of the other layer. Really big slabs, but maybe. 100-kilometer wide synclinorium. Formed by strongly folded and imbricated. So the folds are like. The folds are certainly suggestive of the supernova. Not just the overall arc of it, but the way it folds as well with the arc over and over again. Hundred kilometers. Wow. An almost completed stratigraphic record ranging from the Upper Proterozoic. Whoa. Maybe there was oceanic crust there in like one place. That doesn't make sense. Upper Proterozoic. Usually they don't find signs of some other time frame than what I'm really kind of thinking. Like to the point where it's outside of the epoch or whatever. Upper Proterozoic means basically we're talking Venus, in my theory. And so, which is true, so. Or at least as far as science will ever be able to determine. Yeah. Certainly more true than current science. Whether it's just a stepping stone towards some other greater truth, that there is no greater truth. Just there is no greater truth. Not like, that's it, we found the greatest truth. Good job, dude. You did it. No, not that. Because that's fucking chaos manifest is what that is, maybe. I don't know. All the like subtleties and slight falsehoods that just tweak the fucking reality. So it's like changing the channel. It should be this real truth, but because of the subtle mistruths within of the like temporary interpretations of stepping stones along the way, they're not that stable. Maybe not the best. Maybe that there is no greater truth. It's just simply good enough, and like to stop looking for it, because that really does have side effects. But how to hold on to that and not like access it at the same time, it doesn't make any sense. That's why I like to hope that things will just work out, because that makes more sense to me. Maybe that's a little unreasonable. It makes more sense to me that things will work out than that they won't, so That's how I'll see things until I realize life, doesn't give a shit about me. And that's that. Oh, okay. Alright, indeed. Underlying low to high grade rocks is usually. Okay, let me go back. Stratigraphic analysis of these sediments yields important indications on the geological history of the northern continental margin of the Indian subcontinent, from its Gondwanian evolution to its continental collision with Eurasia. Transition between the generally low-grade sediments of the Tethys Himalaya and the underlying low to high-grade rocks of the high Himalayan crystalline sequence is usually progressive. But in many places along the belts, this transition zone is marked by a major structure, Central Himalayan Detachment System, also known as the South Tibetan Detachment System, or North Himalayan Normal Fault, which has indicators of both extension and compression. Oh my god. All of this so far is still feasibly within the confines of a supernova. I don't see anything that's like absolutely unequivocally disproven my line of reasoning. I know it's a lot to consider, but I haven't found anything that's. This is a little anomalous. Like, of all things, for them to say upper, I do believe upper Proterozoic means early. Although upper might mean late. I don't know. Upper. Oh. Oh. Oh my god. There. So that fixes that. There. That was a little like, what the fuck? I literally was a little like, what the fuck when it said that, because I thought they were saying 22.5 billion. But upper Proterozoic is actually the most recent portion, which is also late Proterozoic, which I wish they would just use the same phrase at least. Besides the point, okay, good. It's preserved within this. Okay, that really, like, it literally clears that up, so that's not. It just basically at this point, it zeroes in on that in order for what I'm saying to be true. It really does strongly suggest that there is a beginning of the process that really did begin just before the Cambrian in the Ediacaran. And that's where Dwarka was attacked, in the Ediacaran. And the reason I personally went off of a Pangea approach is because back then it's hard to tell what was going on, because we basically throw these orogenies in to really go back before Pangea further. The orogenies are such critical features that it's hard to go back that far. Okay. Like, without errors that are already so prevalent in our understanding that they just make the thing unusable. I really don't think the Gondwanan type maps are very true, because they just have like too many conveniences, too many convenient things, just literally convenient. Not like because of the accuracy of the model, kind of convenient, but because of like where it's like, wow, that observation is explained by that model. It's really just like oh, we need to explain this, so there must have been this thing going on, and so add detail. Add detail. It's kind of like the Big Bang does. Add expansion of space. So now we have end expansion of space. So then we have like Pangea plus also this portion needed to like crash in here, so it must have at some point been separate. So let's make it so it moved away. We also know that before then it was actually still together with the thing, so it had to be together, move away, come back together, crash. And that must be how mountains are formed. We'll call it the Wilson cycle. And literally just making shit up to fill in the gaps at that point, like the Big Bang, expansion of space, just make it up. Dark energy, just make it up to fill in the gaps rather than like following logic and reason at least. Simply subducted. I think, did I finish this one? No, maybe. I did get pretty far through here. So, I feel like I was watching something about this earlier. Mountain Lake is a lake in the Shangtang Plateau of Ladakh in India. The lake and surrounding area are protected as the Salmariri Wetland Conservation Reserve. In a large dome. Oh my god, half dome. That made me think of the half dome, which made me think of Shalograms, where the Shalograms are split, the particle is split. This one's cracked. Wonder if half dome has any Shalogram like. Maybe it's a particle. Somewhere there's a particle. I don't know. This mountain's kind of strange. It's even got a little hat. Little hat. Little hat. That kind of reminds me. What's up, guys? Of Shalograms. Little things, extension things on them. Not to suggest this is Shalogram-like, but it does remind me of the way particles probably would function on different scales by splitting. Maybe there's something to it there. Just speaking at that point, though, nothing really. Nothing relevant to that, really. Probably doesn't matter. Metamorphic rocks represent the metamorphic equivalent of the sediments forming the base. Precambrian Phi Formation is also here, intruded by several Ordovician granites. I don't like that it quotes this, but it doesn't. Was that what it said? Phi, like PHE? idea. Maybe if I added Himalayas, but that's whatever. Lead Permian. Believe that's like 252 million. No, Pangea. It's crazy how many Wikipedia articles they have on the Himalayan features. I mean, they seem to just be like a paragraph for the fault lines and structures like this. Maybe this one's got 3. Main problem, South Tibet detachment expected. The method of emplacement of the GHC, Greater Himalayan Crystalline Complex, between the Lesser and the Tethys. It's one of the major faults, let me say. Suture zone. Whoa, it looked like that fault line is like, it's dendrites. Fault line, main, or thrust. Main central thrust. It curves around, curves around, curves around. That is how Shalograms can do. Let me find a good example real quick to plug in here. I'm thinking of one specific one, that's why I'm scrolling through. This probably is good enough. Where was it? I just was looking at it. I literally just looked at it. There it is. Oh no, that's not it. No. Where? Maybe. I'm looking for the one that has like dendrite structures. Like this kind of stuff. Very much reminds me of this. Very much. These fault lines, the orange one, the black triangles. Many of the problems and disagreements that geologists have with each other concerning the Himalayan orogeny involve the relationship between the observed geometry or structures with the various rock units. There are 3 primary rock units present in the Himalaya: the Lesser Himalayan sequence, Mainly low-grade Proterozoic meta sediments. Lesser Himalayan sequence. Yellow. It's like the froth of the wave. Blue on map. I don't know. The greater, largely high-grade Paranesis migmatite. Yellow is low grade, orange is high grade. Let's just make sure I ain't looking for all that, goddamn. Generically character hydrous mineral. Here we go. Just fucking pictures. Yeah, okay. So it's pretty much just dense, compacted, structured. One unit. The more it's able to be just a unit, maybe. Found by reading about the geology of Nepal. Because the Himalaya form on the leading edge of a collisional column, many structural features will form in this area. Three main rock units all have a hotly debated relationship with each other involving two main fault lines. One is the main central thrust. Other is the South Tibetan detachment, which I might have had up here somehow. Tectonics geologists agree that the where is it? Greater Himalayan Crystalline Complex between the lesser, and the Tethys Himalayan straw sequences is between these two faults and is somehow being moved towards the surface and being exposed today. Crystalline Complex. Between the lesser. Tethys. somehow being moved towards the surface. South Tibetan detachment is often interpreted as a low-angle normal fault and can also represent extension. Can also be a north-directed thrust fault. They're like really trying to make go the direction opposite of the motion. Oh my god, literally they're trying to make it that way, or we are. I don't want to separate myself from where it's convenient. Oh, they. What they are doing. Did you see what they're doing? So what we're doing is, it seems we're trying to figure out ways to be like, "Ah, it must be a north-directed thrust fault. This is Earth. Stupid Earth. You're stupid Earth. Why don't you fucking thrust more appropriately so it's obvious, or Earth? We all know India crashed into Asia, so just show it so we can move on. Alright? It shows it. We're moving on. See? Pardon me, guys. I don't actually know what you're talking about, so maybe there's some basis to whatever it was, and not even this, like, interpreting it appropriately. Oh. This was actually pretty interesting sounding. If I can get a PDF, it would be cool. Download. Just real quick, see if we can get an actual comprehension for what the hell is happening. I might stop here soon. It's been over 2 hours. Yep. 2:20. I didn't make much progress again. I just thought it would be kind of fun to start recording my researching. Who knows, maybe I'll make some major discovery and it'll just be like really documented. Not that I haven't made major discoveries already that are really documented, actually. But, like, because it's insightful. It's literally that insightful that I feel it's worth it. I know people just think I'm just megalomaniac ego dude who's just like must be on drugs, and he is, so it just adds to the fucking no, but again, just we low angle normal sense faults. Juxtapose rocks examine from middle or lower. Normal sense structures at low angles, less than 30, apparently contradicted conventional fault mechanics, which for a time delayed their recognition in the field. Interesting. Interesting. Although blah 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 formed in extensional settings have now been studied intensively for several decades, debate continues about their initial orientations. Low angle or high angle. The relationship between near surface brittle faulting and ductility. Deformed tectonites exhumed in the footwall. It has become increasingly apparent that origin, strike parallel, low angle normal sense faults can form during crustal and lithospheric scale contraction as well, e.g. in the Himalayas. It's a paper about the Himalayas, isn't it? I guess it's South Tibet. Okay. Best study example is the South Tibetan of a sin contractional downward contract. Low angle top to the north faults. Top to the north. Meaning that they slope north, which would be opposite of the direction. That's what I'm trying to find. Like if these are all projecting from and upward from the same point almost. Obviously we would have noticed. They're all fucking projecting from, although maybe we wouldn't. Maybe we would only look as far as like this Tibetan plateau. No further to really pick up on where they all conjoin-ish region. I don't know. Like if there's a bunch of generally parallel lines, we might just be like they're generally parallel and not pay attention to the fact that they focus to a point that's over there. That I feel like maybe that's relevant. Because why would it be? There's no reason it would be in plate tectonics, so no one cares. But if it's an exploding particle under the crust of the earth that literally supernovaed and pushed up a mountain chain, I mean, then it would matter. Oh yeah, it does point in that exact location of where that opening under the Tibetan Tamil, north of Tibet. The opening in the earth is find. Why can I not? How is there no word slope? Isn't that what they put right there? Angle. Oh my god, top to the north. Okay. Maybe I'll just title this one actually research even because it was way too slow, I think, to, it's just too slow. I don't want to make it as if this one, and ones where I'm like especially slow and just more researching. I don't want to like make it like they should be equally watched. Maybe like I like the idea of having them available, but I don't necessarily feel like if I were to become noticed by people that like everyone would be interested, who is interested in what I have to say, like they would be interested in like this, like the yeah, maybe this is a little extreme. Especially considering just the sheer quantity of content I have. It's just a lot of shit to like go through. With the world collapsing around us any moment, who knows who will have access? And then suddenly it's like this weird, like, did you manage to look at it before they shut the world down kind of thing? And then if you did, you'll be like, yeah, I kind of do unfortunately see the shit he's saying now. And, but they shut the world down. So, like, they're controlling the narrative still. And, they don't want me to say the things I'm saying, so. I don't trust the government. Lying ass government. With an S, governments. Governments. Wait, is this? Is this for literally that lady I was watching? Maybe. No. Okay. Well, I think that's a good stopping point. Until next time, peace.